Welcome to Chemtech Laboratory Tutorial. Today we'll be looking at organic compounds and we are going to navigate through the naming, and also we'll do more videos to explain the reactions of organic compounds. Organic compounds are divided into two. We have the aliphatic organic compounds and we have the aromatic organic compounds. Before we move ahead, we need to know what organic compounds are. Organic compounds are the compounds of hydrogen, carbon, and any other element. And these other elements could be oxygen, phosphorus, nitrogen, and any other elements like metals too. They can be found in organic compounds. But these organic compounds are measured into two. We have the aliphatic and we have the aromatic. Under aliphatic organic compounds, we have hydrocarbons and we have non-hydrocarbons. What are hydrocarbons? As the name implies, hydrocarbons is the chemistry of just hydrogen and carbon. It is chemistry of just hydrogen and carbon. And these hydrocarbons are classified into alkanes, and alkynes. Alkanes, and alkynes. While the non-hydrocarbons are chemistry of hydrogen, carbon, and any other element. And those any other elements could be heteroatoms. What are heteroatoms? Heteroatoms are atoms that are in the periodic table outside of carbon. That means we can say oxygen is an heteroatom, sulfur is an heteroatom, metal is also an heteroatom. So what type of compounds can we get that are hydrocarbons, that are not hydrocarbons in organic compounds? One, we have the alcohols, we have the amines, we have the carboxylic or alkanoic acid, we have also the ketones. We have the ketones. Ketones can also be called aldehyde. We have the amines or amino alkanes, and so many others. Now, this aliphatic can be classified into straight aliphatic and cyclic aliphatic aromatic organic compounds. And these aromatic organic compounds are into benzene, and benzene derivatives. Benzene and benzene derivatives. So that is all about the tree of the organic compound. Now we'll look at it one after the other. What is the aliphatic? We will look through as aliphatic being divided into two. We have the normal aliphatic and we have the cyclic aliphatic. The normal aliphatic, which I call normal, can also be called a cyclic aliphatic, meaning they are hydrocarbons that do not contain any cyclic compound. They are hydrocarbons that do not contain any cyclic compound. They can be straight chain or branch chain. That is the acyclic aliphatic compound. What are the examples of that? We have propane. We have 2-methyl-propane. 2-methyl-propane is a branched propane, while propane itself is a straight chain propane. Then we have the cyclic. The cyclic aliphatic compounds are those organic compounds that contain at least a ring in the organic compound. And these examples are cyclopropane, cyclobutane. When we have a cyclic compound, we call it cyclo. We add the word as CYCLO. So it can be cyclopropane or cyclobutane. So we will look all of that under aliphatic hydrocarbon. Okay, now we'll be looking at functional group and homologous series. The main reason we need to look at this before we start looking at the aliphatic compound properly, so that we'll be able to identify which is alkane, which is alkenes, which are alkynes, and also what kind of family can you classify an hydrocarbon into. So what are functional groups? Functional groups are groups of atom or atoms or bonds that represent the chemical properties and the physical properties of an hydrocarbon family. That is functional group. Example, we have a bond. A bond is a functional group of alkane. Then we have double bonds. Double bonds is a functional group of alkenes. Then we have triple bond. Triple bond is a functional group of alkyne. This is how you know which family does a compound belong to. Then when we now look at the non-hydrocarbons, we also have their functional group. It is the functional group that tells us whether it is an alcohol, whether it is ketones, whether it is an aldehyde. So for example, we have alcohol. Alcohol functional group is a bond O and H. So we say this is what? Alcohol. Then we have carboxylic acid. The carboxylic acid is represented with C, a bond, C double bond, double OH. And it can also be represented structurally as bond, C, double bond, then OH. So it's either you represent it in a written form or in a structural form, and this is called alkanoic acid or carboxylic acid. So we have so many functional groups. So when we are taking them one after the other, we will explain each of the functional group and the properties and how to know a compound that is having a particular functional. We have the homologous series. Homologous series is the series of compound in a family that differs by CH2. That differs by what? CH2. A series of compound in a family that differs with a successive member of what? CH2. And this homologous series help to tell us that as the carbon atom increases, the physical properties changes, and families of the same homologous series have the same chemical properties, and also they are prepared in the same way. That means you can prepare them with the same chemical method. So that is homologous series. And if you calculate the molarity of CH2, you see that the molar mass of CH2 is 14. So you can also say that homologous series differs with their successive members with the molar mass of 14. So how do you know a series of hydrocarbon that belongs to the same family? So we are going to take example. We have the alkane. Alkane have a general formula because an homologous series must have the same general formula. Homologous series must have the same general formula. The general formula of alkane is CnH2n plus 2. So what are the families? Well, just like a father and mother having children. So what are the children of this father? That is how we identify alkane. Alkane, with the surname of alkane or the suffix of alkane ends with ane, meaning that every member of that family must end with ane. So if I put 1 N to be equals to 1, it means I will say CH4, and this CH4 becomes methane. So one carbon is called meth, and the family is N. So now if I put the number N to be 2, it means I have C2H6, and thereafter we will have this as ethane. So 2 compound means it, and the family is N. So we have, when N equals to 3, we have C3H, 3 times 2, 6 plus 2 is what? 8. So it is called propane. Propane. That means the 3 compounds, the 3 carbon is called pro, and the family is pane. So that means we call it propane. We want to say homologous series of alkane. It means 2 from 1. This is carbon, this is carbon. 2 carbon from 1 carbon gives us 1 carbon. A6 minus H4 gives us H2. So the same thing, when you separate this from this, you will still have CH2. When you separate these two, you have CH2. Let's put C4H10, which is butane. So separate the two. What is the difference? CH2. So that means this is the homologous series of the family of alkane. But you cannot say alkane is an homologous series of alkane. No. Why? Because they have different names. This is alkane. Alkane is represented with a single bond and a general formula of CnH2n. So the same members of family must have the same functional group, and they must have the same naming, the same suffix, which is ane. For example, for alkane, alkane is the same thing. For alkane's family is ene. For alkyne family is yne. Thank you for listening, and God bless you. So in our next video, we will talk about the carbon itself. For watching this video, please don't forget to like, share and subscribe.